So the difference between adding and subtracting radicals and multiplying radicals, it's still kind of along the same lines as variables, but this time you multiply outside numbers together, and then you switch over and multiply the radicals together. And then you simplify the radical, if it can be simplified. But don't cross over the radical mark. Outer and inner are never combined, unless you, of course, square the outer to move it back inside. So, this is why it's important, though, as like I said, as we go through today, you're going to see where it's important to have a 1 in front of the radical when it is sitting there. So I'm going to go ahead and sit it there. So this time, you'll just say 3, radical 6 and radical 10 are both simplified. So 3 times 1 for the outside gives us 3. And then you multiply the radicals. Radical 6 times radical 10 gives us radical 60. All right, that would be it if 60 were simplified.
5 and 12.
But we can put 5 and 12. You could do 6 and 10, 3 and 20. But I like doing 5 and 12. Are either of those simplified? Or perfect squares, I should say. No. But we can break 12 down into what? 3 times 4. Are either of those perfect?
4.
The 4. And it comes out as a what, Gaines? 2. Now, it's over here as a 2, but what is it going to be combined with?
3.
The 3 that's already outside. So times 3. What's left inside
5 and 3.
the 5 as well as that 3? And what's 5 times 3? 15. So 6 radical 15 is your final answer.
If you move the 3 over there, then why is it still like?
No. Finish your question. I'm not following you.
Well, you did 2 times 3, so.
That gave us 6. The 3 was already outside the radical before we
I was
started
looking at the
simplifying the
other
60.
I was looking at the bottom 3.
Oh, that's inside the radical still, combined with the 5 to get 15. This 3 came from that 3, the outside part. Does that make sense, though, Luke? Is that okay? Now, 3, you work it. Should be pretty straightforward. Because you've just sort of worked it. What's the radical?
2.
15.
Oh, wait. I was.
When you multiply, you get radical.
15.
Radical 60.
You get radical
Oh,
60,
I was gonna say like the final.
and then the final.
15.
Not all.
Oh, not 2 radical.
2 radical 15. That takes us back to just the breakdown of 60 that we just did. And the only perfect square we found within 60 was the 4, which comes out as our 2, and we're left with that 3 and 5, which gives us 15. Good with that? All right, we're moving to 5. You work 5. 5, 4, 3, 2, 1. What's the answer?
4 radical 10.
4 radical 10. Nothing breaks down.
So when nothing breaks down, it just stays.
Yep.
Can you write number 2?
There it is. We took 60 because we. Oh no, I'm not working 2. We're in the odds.
But I'm confused.
So let's look at 7. Could either of those be broken down?
Yes.
And here is my suggestion. Yes, you could say 15 times 20 and work 300. Or, you know, when you're simplifying fractions, when you're multiplying fractions, we always say cancel out before you multiply so you're not working with big numbers. I highly recommend that for this. So 20, what does it break down to?
2 radical 5.
So it's because it's 4 times 5, so that gives us 2 radical 5 times radical 15. Now we're still going to have a big number. So what would radical 15 times 2 radical 5 be?
2 radical 30. Wait, no.
Nope, 2 radical 75. Now, 75.
Oh, wait.
Nope. What did 75 break down? Two multiples of 75.
25 and 3.
25 and 3. Good, Kendrick. 25 and 3. Anything perfect?
25.
25. 25 comes out as a 5. It's going to be multiplied by that 2. So that's 10 radical 3.
Where do you just get the 2 and 5 from? The 2 radical 5?
20 broke down into 4 times 5. 4 comes out as a 2. So 20 is 2 radical 5. And then we did the multiplication and got 2 radical 75. 15 times 5. The radicals multiplied. Then we broke 75 down into 25 times 3. 25 comes out as a 5. Because it's perfect square. Multiply those together, and the only thing left is the 3. All right, I want to show you something super quick. So I'm going to write our answer here. 10 radical 3. And I'm going to erase. Another way to do it where you're not having as much multiplication to do is this. Go ahead and factor 15. How would we break 15 down just as factors? 3 times 5. How do we break 20 down as factors? 4 and 5. So I'm going to write it though, 5 times 4. 4 is a perfect square and comes out as a 2. Look, we have 2 5s.
5.
They come out as a 5. 5 times 5 is 25, which gives us 5. And what's left behind?
3.
The 3. So 10 radical 3. And that way you're not having to go like 75.
What if
And
they're both prime? There's
well, if they're both prime,
never mind.
like number 5, we had 5 times 2, 10. I mean, yeah, that you wouldn't necessarily have to break it down. Okay, look at number 9. What does it say do?
Just do the
Distribute. Now, remember, you can't, I heard that moan, you cannot cross over radical to inside, to outside and inside radicals. Do not play, okay? So, when we distribute here, though, you're going to say radical 10 times a 4, which gives you what?
40.
No, don't cross over. 4 radical 10. Now, you're going to hear me say this a lot in this class when we're working with radicals. The next distributed number, radical 10 times radical 10 is radical 100, which is 10. Anytime you multiply a radical by itself, like the numbers are the same, it's the number inside the radical without the radical sign. Like radical 3 times radical 3 is radical 9, which is 3. Radical 2 times radical 2 is radical 4, which is 2. So you see what I'm saying? So when you multiply 2 radicals together that are the same number, you'll end up with radical 100, which is a perfect square, and it's 10. And that's your final answer. Because even though there's 10s involved and 4s involved, this is back to adding and subtracting. We can't combine radicals unless they're like terms. And so the 4 and 10 can't combine, and the 10 and 10 can't combine.
Can the 4 and 10 not simplify?
Nope, because this is like saying 2r plus 4. And if you have this, whoops. Can you do anything more with 2r plus 4? Even though the 2 and the 4 share factors and all that. We can't do anything with it. So you work 11. So what'd you get?
3 radical 5.
1 radical 15.
1 radical 15
Plus 3.
plus 3.
You have to put the one.
You do not have to put the 1, we're just encouraging.
Oh, I get it.
So at this time, it's two radicals being multiplied together. So radical 3 times radical 5 gives us radical 15. And then radical 3 times radical 3 is radical 9 plus 3, which becomes 3.
Why isn't it a radical three?
Why isn't it a what?
Radical
It's
three.
radical 9. So.
Radical 9 is a perfect square. Remove it as a 3. All right, questions before we go to the back page? Aiden,
I'm confused about this.
which part?
Just like the way we get that, like, do we four?
No, we don't have 2 in parentheses yet. We will. All this is distributing. This is like if we have 3r
What
times r plus 7.
What happens when they don't go into each other like 12?
You're
So we distribute the number outside the
parentheses. You saw 3r squared plus 21r when we did this. So it's the same thing. Radical 3 times radical 5. Those are both inside the radical. So you can multiply those numbers and we get radical 15.
What about the other radical three?
Radical 3 times radical 3
9, then
is radical 9, which is 3. Anytime you multiply a radical by itself, it's that number without the radical.
so, but it would be outside the parentheses at.
But there's no parenthesis
Or-
once
well,
we
it'd be out-
distribute.
No, no, it would be outside the radical added.
Mhm.
Okay.
All right. Let's go to the back page. Okay. I know it's fun. Radical. Okay, let's kind of, this is going to be a little bit of simplifying going on here. So take your outer number. Let's do those first. So negative 4 times 4 is what?
Negative 16.
Negative 16. Then we're still working with that first number. Radical 15 times radical 10.
150.
150.
30 and 5.
You're like on this.
How do you just know that?
Well,
5 and 3.
well, not really to 30 and 5. 30 and
35.
What?
30. Yeah, because he's looking at 15. 3 times 5. So it's going to be 30 and 5.
Would be easy. I didn't know you could do that.
No, it wouldn't.
Wait, what would be easier?
What, you just break that 25 and 6?
Yeah,
Uh-huh, because you can break, yeah. And then, but let's finish up the next part. This is where, don't forget, you have a negative 1 out front. So negative 4 times negative 1 gives us plus 4. And then radical 15 times radical 2, radical 30. Now, we're coming back to the 150, but I'm going to say this about radical 30. I personally think radical 30 should be able to break down. There's got to be a number in there, but it didn't. That's a big number, but it is 1 times 30, 2 times 15, 3 times 10, 5 times 6. None of those
Stinky.
are perfect squares. So radical 30, while it's a big one, it remains radical 30. You don't have to break it down. But we're going to go to 150. And I've heard several things. Who said it?
30 and 5.
I heard a 25 times 6. I think that's a, why would we do that one? Why is there a calculator out? Put those calculators up. You weren't. So, yes, now I will say this, you could start with 15 times 10. There's things you can do, but look if you can for the perfect square.
Does 18 have a radical? Is 18? No. Oh,
So 25 comes out as a 5, and it's going to go over here and multiply with the negative 16. Can we break 6 down? No. So what's negative 16 times 5?
Negative 80.
Negative 80, radical 6, plus 4, radical 30. And we're done. You work 15. Distribute your numbers, distribute your radicals. We've already discussed 30, it can't break down.
18 is scary.
Mm-mm.
I know.
Negative 10 radical 30 plus 6 radical 6.
Almost. I love a negative 15 radical 30. That works.
Stop.
I mean, so negative 10 radical 30.
Plus 6 radical
Ooh.
6.
Nope, that part didn't work.
Is it negative 10 radical 30 plus 18 radical 2?
I got 18 radical 3.
18 radical 2.
What?
Negative 6 radical 30. I mean, negative 10 radical 30. So we had 2. There it is. 2 times negative 5, which gives us negative 10. Negative 6, radical 6 times radical 5, radical
Oh.
30. We know that can't break. 2 times 3 gives us 6. And then radical 6 times radical 3 is radical 18.
Would you do foil for 18?
18, radical 18 breaks down into 9 times 2. And the 9 comes out as a 3.
Negative 10 radical 30 plus 18 radical 2.
Plus 18 radical 2.
You said yes.
But why doesn't negative 10 and 30 simplify?
Remember, we talked about 30 and all the factors of 30.
Whoa.
1 and 30, 2 and 15,
Bill?
3 and 10, 5 and 6. None of those are perfect squares.
I did 3 and 6 for 18,
Mm-hmm.
but I didn't get the right answer.
Okay, trying to encourage you to always, for 18 or any number you're breaking down, look for a perfect square. So, but let's do it. 18, 6 times 3. None of that is perfect. But 6 can break down into 2 times 3. And then the 3 comes, so you have 2 3s. That becomes the 9, comes out as a 3, and you're left with the 2. Still can work it, just remember to look for your pairs. All right, erase. 17, use your math. What are we doing?
Foil.
We're foiling. First, outer, inner, last.
So what's the answer for 15?
For 15,
Yeah.
negative 10 radical 30 plus 18 radical 2.
It's the one box everything.
The one with the box. Thank you, Sam. So, we remember to go first. So, for 17, negative 4 times negative 2. Times positive 2. We get negative 8. And then outer, negative 4 times, and there's a 1 in front of that radical 5. So what does that give us? Negative 4 radical 5. So negative. Oops, hold on, I wrote the wrong number. Negative 8. I moved this down a little bit. So minus 4 radical 5. What's our inner?
2 radical 5.
Plus 2 radical 5. And our last.
1 radical 25.
No, radical 5 times radical 5 is radical 25, which is 5.
Oh,
Plus radical 5.
Plus 5. No, plus 5.
Oh, 5.
Then, because it's a radical
No.
25.
No.
Then you take your like terms and combine. Negative 8 plus 5, negative 3. Negative 4 radical 5 plus 2 radical 5. Negative 2 radical 5. Now you could say negative 2 radical 5 minus 3, either way.
wait. Why is your answer do you not like add 3 and 2?
They're not like terms.
Oh, the 2's like connected with
The 2 is, yes, because it would be really technically
Oh, no.
2 squared is 4, and then move it inside, so we're looking at like a 20 right here. They're combined. If it's a number outside the radical, it goes right with that radical. Don't separate them. So 19, I'm gonna see what you do with 19.
Wait, Dr. Graham,
Mm-hmm.
I'm confused with 17.
Okay, where?
We had -4 radical 5 plus 2 radical 5,
Mhm.
and when we combine them, wouldn't that be?
It's
We're adding the. I thought we-
This is like, now we're stepping into the addition subtraction lane.
Oh.
And so where it's combined like terms.
Oh, so once we FOIL, we add.
Mhm. Remember like when we were foiling back in the day, we would multiply, 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 and then add like terms. The outer and inner usually combine. All right. 19 is gonna have 4 clumpies. Nothing combines there. You may have to break some stuff down, but nothing combines. A pencil. Nope, not yet, but I'm looking.
Okay, yeah. Okay.
Except here, I've got a crazy thing to hand you. It's a pencil on both ends, but I have a baby eraser. These things I find along the way. All right, what'd you get for 19?
2 radical 3 plus 1 radical 6 plus 2 radical 2 plus 2.
Perfect.
What?
So 2 radical 3. Guys in the back side, shh. That's radical 3 times radical 4 gives us radical 12. That's 4 times 3, so the 4 comes out as a 2. So 2 radical 3. Then your outer is just plus 1 radical 6, or if you say radical 6. Your inner is radical 8, which is 4 times 2, so that's 2 radical 2. And then radical 2 times radical 2 is radical 4, which is 2. And none of those are like terms.
Is it 2 radical 3 plus 1 radical 6 plus 2 radical 2 plus 2?
That's it. Okay. Which one do we want to do? 21 or 23, y'all pick one. Just do 21. Oh, yeah, we do want to do 21. All right. Y'all want to do it together, or you do it by yourself?
Together.
Together. All right. So -3 times -4. Positive 12. All right. Radical 3 times radical 3 is radical 9, which is 3. So that means 12 times 3, which is 36. Outer. -3 times 4. That's -12, and then just the radical 3 rides along. Okay? Inner. 5 times -4, -20, and the radical 3 rides along. And then last, 5 times 4 is 20. Then you combine, positive 20. Then you combine like terms. 36 and 20, 56.
Whoa. How's it not -20? Inner?
I'm confused.
Hold on,
Oh, wait, never
outer.
mind. First.
Well, the outer is
I
going to
didn't
be
see that.
negative, and the inner will be negative, but the last is positive.
Okay, sorry.
Then -12 plus -20.
32.
Negative 32, radical 3.
I don't like these big ones.
I don't get this one.
Did you get 36 for first?
Why can't-
Yes.
Okay, and then outer, negative 3 times 4, the outer parts of the outer, negative 12, and then that radical 3 just stays radical 3. And then the inner is 5 times negative 4, so that's negative 20. And the radical just comes along. And then the last are both outside numbers, so it's plus 20.
So the negative 12 becomes negative 12 radical 3?
Right, because it had, the negative 3 had a radical 3 with it, and the negative 4 had a radical 3.
I don't like how.
So that's add your like terms, 56 minus 32 radical 3. Those were like terms right here, and these are like terms. All right. Jump to,
We do 23.
in a second, we will do that. We'll come back to it. I want to make sure you're good with 18. So radical 5 plus radical 2 means, squared, means radical 5 plus radical 2 times radical 5 plus radical 2. And you FOIL. So radical 5 times radical 5 is 5. Radical 5 times radical 5 is radical 25, which is 5. The outer is what? 1. This is where it's important. 1 radical 10. The inner is also a 1 radical 10. Last, radical 2 times radical 2, which is 2. 4, because it's radical 4, so 2. Combine like terms.
7 plus 2 radical 10.
That's why I want the ones out there, so that you'll be sure not to skip that. So 7 plus 2 radical 10. And that would be your final answer. All right, run back down to the last one.
Would your answer to 20 not be the same thing?
Could be. So 23. Handle that one. And tell me what you got.
Same thing. Oh, wait.
23. So what'd you get?
Negative 11 minus 2 radical 5.
Oh,
I got
almost.
minus one.
-1.
That's one radical.
Which one are we doing?
23.
Oh, I did 20.
Negative 11, because you would have had 3 minus 4. Okay, your homework is evens. 10.